Hi, Irvis. This paper presents RiskFix, a package supporting domain experts in validation of predictive time series models in high-intensity settings. It's a result of our experiences as data scientists and domain experts working together in a pediatric hospital's intensive care unit. In such a fast-paced, high-intensity environment, traditional validation approaches are not possible, and predictions can only be validated in the moment and by domain experts. In such contexts, domain experts cannot exert time or effort beyond what is typically allocated to assessment of the situation in their practice. Our work sheds light on the human factor constraints that exist in support of model validation tasks in these contexts. Central to supporting such constraints are two information flows. The prediction flow, in red-orange, starting from the left, responsible for communication of predictions from the model to the domain expert, and the validation flow, in blue, starting from the right, responsible for the communication of feedback on the model predictions from the domain expert. Facilitating this informational exchange is our tool, RiskFix. In RiskFix, the model's prediction is presented to the domain expert through this trendline component. The tool provides the appropriate visual support for the model output data type and the appropriate update frequency of new predictions according to the domain expert's validation needs. In this way, RiskFix allows domain experts to give feedback to the model on performance in a way that minimizes the cognitive effort required for such tasks while simultaneously preserving the feedback data's usability and usefulness to model validation and calibration. RiskFix supports predictive models that output a new time series data point as it becomes available, like a continuous or discrete score that's generated at regular time intervals. For instance, a model estimating a risk score based on continuous monitoring of a clinical instrument's measurements, as we have here. With that, let's quickly cover the design requirements we considered when designing the RiskFix workflow.
With RiskFix, we aim to provide an optimal compromise between a tool that collects useful and usable data labels from experts at the time of patient assessment, while providing a smooth and seamless user experience.
To summarize what my colleague Arnav told us, when dealing with communication of model output, presenting too much information, like showing a new prediction every second, or showing a precise predictive value when a broader categorization would have sufficed, can be overwhelming to the user. And this makes it practically impossible for the domain expert to thoughtfully validate a model. To this end, we ensure that RiskFix uses components already within most users' data literacy level. This means a traditional line chart representation to convey the model prediction to the domain expert, and that RiskFix accounts for the cognitive load associated with the assessment. That means supporting tasks such as comparing values and providing feedback. When handling the collection of feedback input, we need appropriate input modality for the feedback data type collected and appropriate timing of feedback collection, all based on considerations for the usability and bias reductions for our domain experts, as well as the data richness needs of data scientists. To this end, we ensure that RiskFix uses the feedback input modality best suited to user needs and the device type via prediction correction interactions that include drag and drop and free text submission, most appropriate for the ordinal and the textual data we must collect via the tablet touchscreen interaction that RiskFix leverages. And finally, that RiskFix minimizes the burden of validation effort. Our central interaction paradigm is such that the tool assumes that the expert is in agreement with the model unless explicitly otherwise specified. This is because collecting labels shouldn't ever be burdensome. Okay, now let's see RiskFix in action by going through a user scenario.
Imagine Emma, a pediatrician assessing the risk of cardiac arrest in the patient. Scanning through the vitals and the patient's general state, Emma forms an expert opinion on her own. To provide input to the predictive model under evaluation, Emma has RiskFix open on a tablet while at the bedside. She scans the QR code to get RiskFix running on this patient. Emma is now all set to begin our prediction validation workflow. First, she is presented with a pre-bias survey. That is, Emma can enter her expert's estimate of the context risk level before she's exposed to the model to avoid bias. She can drag the risk between low, medium, and high values. This value will be saved along with the timestamp as the current value for the patient without exposure to the model. Emma is then taken to the model validation screen. Here, this time series shows the most recent risk predictions made by the model, which are updated in real time every 30 seconds. While assessing the patient, Emma can compare her expert's estimate with the model's prediction and dynamically correct a value when she disagrees with the model by dragging the latest points up or down. This results in the dashed line, the line corresponding to the expert's assessment, to depart from the plain line, which is the line corresponding to the model's prediction. Note that only the latest point is editable. This is to ensure that the validation is made without hindsight bias. The corrections can then be perused by the developers of the model to validate the model before deployment or recalibrate the model. Emma can also provide general comments and observations, as well as constructive explanations for why she disagreed with the model. Here, commenting on the breathing of the patient. These freeform annotations support rich input necessary for the data scientist who developed the model to understand what piece of information the model may be missing, as well as the expert's reasoning behind an assessment.
We evaluated RiskFix in this environment. Our approach included a usability study with 6 clinicians, similar to Emma, and external to our research team. The participants were asked to validate the model by using RiskFix in a simulated, fast-paced, high-intensity environment, similar to their own critical care unit. Our research raises an important question. Even if a model is fast and precise, validation is bottlenecked by the human expert's needs and abilities. It would not be reasonable to scale the resolution of a model to match that of a human's processing abilities. So, given the model and human validator do not operate at the same level of precision or frequency of prediction output, how applicable is the validation feedback to the models? How aggregated validation is to be reconciled with a model still remains a challenge, and its resolution calls for extensive, in-the-moment data collection from experts. We begin to address this concern by applying RiskFix into a large-scale silent trial at our partner institution, SickKids Hospital. This will allow us to observe how effective the tool is at facilitating human validation of the institution's risk prediction model and whether the tool allows clinicians, our domain experts in the study, to feel more confident in a real-world validation process. While we evaluate our workflow on the specific case of assessing cardiac arrest risk in patients, our package implementation approach is model agnostic, and so generalizable to models which output time series data. If you are someone working on a model that will be deployed in the wild, especially to domain experts and in a high-intensity setting, please do visit this link and try out our publicly available NPM package. Bye, Euroviz, and thank you all for watching this talk.